right, everybody, welcome to Season 2, Episode 10 of Building a Second Brain. So, let me check my screens. I can see myself 4 times. So, this should be fine. And also, I've got my ping running. Hopefully, the internet connection will hold up. I've had some outages in the past couple of weeks, I should say. So hopefully this works. And yeah, so I've just returned from iOS Conf in North Macedonia last week, which was really, really nice. It was a really great conference. Amazing organizers, amazing, well organized. I really loved it. Lots of amazing people. I had lots of great conversations with people, and it's always so nice to see people that I usually don't see because I look into my camera. I don't see you guys, but you can see me, and then every now and then at a conference somebody will walk up and say, hey, it's great to see you. I watch your videos, I watch your live streams, and actually there were at least 2 people who told me that they watched the live stream, and that was even more mind-blowing to me because, the Firebase YouTube channel has, I don't know, 300,000 plus viewers, and so the chances of someone that I meet at a conference also watching the Firebase channel are decent. But someone that I meet at a conference watching my live streams, that is truly special to me. So if you see me at a conference or at a meetup and you watch my live streams and tell me that you made my day. So let's see who's here. We've got Franklin, we've got Lars. And yeah, Franklin, so how much of the conference was AI? Let me think. So there was one talk, Stefan did a talk about Apple Intelligence and how you can recreate it yourself because in the EU, not all of Apple Intelligence used to work. Now, as we know, some of it works, but I don't know, like, do we get less or more than our friends in the United States? I think everybody doesn't get a lot of Apple Intelligence because it's still under development. Let's put it that way. So that was one talk. And I think that, most of the other talks did have mention of AI in it, but there was no App Intense talk. I think there was an App Intense workshop though. So Daniel Steinberg gave an App Intense workshop. I didn't have the chance to go, but I heard lots of good things about it. And one fun side fact was that, I don't know if you knew, but App Intense has a dependency injection framework. So, and that was quite interesting for lots of people. And my talk was about the SwiftUI environment and how it is also somewhat of a dependency injection mechanism, but not for everything that you would want to use a dependency injection container for. So people said, oh, it was quite interesting. Daniel just casually mentioned this injection annotation, or sorry, this injection, what's it called? Property wrapper, as if it was nothing. And to most people, it was news. So that was quite funny, I thought. Yeah, see, Franklin also said that he didn't know about it, but yeah, it is there. So I went to an Apple event about App Intense a couple of weeks ago. It was virtual and ran for several hours, and I knew about it, but only because I attended this workshop and I even got to use it. And then when it was time for Q&A, I asked them, so is this just a plain old dependency injection container? Can you use it for anything else? They said, well, you probably can, but it means that you'll have to import the app-intents framework, which obviously is not what you want to do all of the time if you don't use the app-intents framework. And it sounded like they didn't have any plans to make it generally available. So something else that I got at the conference is this really nice badge. So it looks like this. It's got my name on it, and the red thingy at the bottom, that is the stone bridge in Skopje where the conference was. And you know, you might think, oh, it's just a badge, but this is actually pretty sweet because, oh, and then, you know, we also got this really nice power pack. And if you put the, let's see, which way do I need to put it? This way, other way? Well, you can charge it. Oh, here's the light. So you can charge that. So it's a smart card, and you can find it. So if I pull up my Find My, then I can find this card. And it makes a sound, pretty noisy. So that's pretty sweet. And it's also got an NFC tag on it, and that is what they use to tell people, hey, you know, you can easily find the conference program by holding this to your phone, and then it will pull up your app clip for the conference. So that was really nice. So yeah, and so this week is one of the very few weeks that I'm not traveling. I'm traveling again next week, where I'm going to be in Turin again for AI Heroes, and my talk is going to be about a model context protocol. So that's going to be really exciting. I'm going to use what I built a couple of weeks ago, where I created this MCP server for Keynote. And there are some other very exciting things coming up that I can't yet talk about. So for today, I thought, and let me switch to the live view. So for today, I thought we could look into a feature that is pretty new in Firebase Cloud Functions. And let me quickly pull this up. So if you watch our Firebase release note videos, then you might have seen this before. So here's a video that Rosario recorded for April, and it has this feature. It talks about Cloud Functions, streaming callables, and on-call GenKit. So let's quickly go.
Cloud Functions for Firebase now allows you to stream the responses of your callable functions. This means that your Cloud Function can send data to the client in chunks.
Here, but yeah, we can read the transcript here. So it basically says that you can use this feature. Oh yeah, that's already it, right? So it's very short. So it basically says we now support streaming functions, and the example. I should maybe pause, right? Okay, so here we go. Okay, so the example that the documentation shows is a weather forecast API, and you can basically go in and get the forecast for several locations. Let's say we want to get the weather forecast for Munich, for New York, for Skopje, and then lots of other locations, let's say 10 locations. And getting the weather forecast, you know, maybe for some of those locations, the API that we're calling might already have this data at hand because somebody has already asked for the weather forecast, so it's already fresh. But for other locations, it might not be readily available, so the backend might have to make a call to the remote system that actually gets the weather data. So that might take a while. And that means if you have your screen where you show all those temperatures, you might, you want to show the different weather forecasts for those different locations to the user as they arrive. So let me pull up the Apple weather map so we can get a better understanding. So let's assume that you have a screen like that where you have the list of all the locations that you're interested in, and then it takes a while for the weather for London to arrive, maybe, because nobody's interested in the weather in London because it's always, no, it's not always rainy, but you get the idea. So, and while this is great, for our use case, I think it's slightly different because let me show you something. So if we go into our application here in our second brain application, and when we go into our chat window here, and let me see, so let's ask something about SF. Let's ask it about Data Connect maybe. Okay, so, oops. How can I model data in Firebase Data Connect? So now, oops, what's happening here? Oh, there we go. All right, so see, it's so surprising that even I, who built the app, was surprised by this. So what happens is we send the request, and then it takes a while for the model to generate the answer, and then the answer is being returned, and boom, it appears, and we don't get any idea of, oh, that the answer is building up. And this is probably something that is very specific to LLMs, because everybody by now is used to the answer appearing line by line, because it takes a while for the answer to be generated. So this is very, very specific. I assume that once models get so fast that the answer is there pretty much immediately, we'll have to think about other UI metaphors, right? Is it going to, can we show the data pretty much straight away? Maybe yes, maybe no, right? So if you imagine that the answer is maybe shorter and the answer is just 4 lines of text and it arrives pretty much instantly, then you can probably show those 4 lines of text immediately. But if it's a longer text like this one, or maybe even longer than this one and goes on for several pages, then you would probably want to show this gradually and animate the text as it comes in, and show the user the text as it arrives. And probably also, you don't want to scroll. Just imagine that you ask your question, the text arrives, and then the whole thing scrolls out of view. That would be pretty annoying, I think. But what I want to do today, I want to explore how we can use this new streaming feature for our app here. So I obviously did prepare this, but it's been a while, so it's going to be as if I hadn't done it before, because I'll have to figure this out as we go, which hopefully adds to the whole experience. So the first thing that we want to do is we want to go into our code editor, and I've been using Cursor, and you can see that I've got my app running here, and here is my watch, and here is the log. So Franklin asks, are you putting an animation before the stream? So that is a very good question. I think we should. The question is, will we have enough time to do it today, or is it something that we'll do next time? But let's build the thing first, and then we can see if we can get to the animation. So let's go into the documentation, and So this is the, let's see, this is the documentation for Cloud Functions, where it shows us how to invoke GenKit flows from your app. But before we can do that, we need to go into the function where we generate the response. So, and then let's just search for stream. Okay, here we go. So, and this is the documentation that explains how we can stream a response. And you can see that there is a function that's called generate stream, and we get an object that we can deconstruct. Part of that object is the response object, probably, because it's going to be much more than just a string, and then the stream itself. And on that stream, we're going to receive messages or chunks. And you can see down here how you would consume that. So let's imagine that we have a TypeScript application where we want to consume the stream that we produce. This is how it would look like. You get your stream, and then you use a for await loop to asynchronously iterate over the stream as you receive chunk by chunk. And those chunks are the fragments of the response. And then, once the stream finishes, you will be able to await the text property on the response down here. So you can get the entire text as well. And that is useful if you gradually want to upgrade. And I think it'll be really interesting to explore this today, because I'm going to update the backend implementation first. And if things go well, that means that our client won't have to be updated immediately, and it will be able to work with the backend implementation. Okay, so let me put this to the side, and then we're going to go into our code editor here. So, and then here where it says AI.generate, I'm guessing, is this large enough for you guys? Let me double check. It's pretty small, right? Can you read this? I'm going to make this a little bit larger. Do you? Oh yeah, so I'm interested. Seems like you recuperated quickly from the conference, back again in the grind. Well, yeah. We even had a bunch of friends over on the weekend, and we had a barbecue party. So I enjoyed the conference, so it was really good. Yeah, so I was, can you please tell me how you watch this? Can you let me know if you watch this on a MacBook, on a computer screen, on a laptop screen, or on a large screen, or if you even watch this on a phone, so I know, next time. So AI.generate, we want to use generate stream. So let's see, and it seems like we could basically just replace this. So let's just try this out and see if the compiler starts screaming or not. Okay, so this works, but the response is obviously different. So, and it says the property output does not exist on the type generate stream response, and it seems like it returns a summary and an answer, which oh, and then await has no, but this, I think that wasn't it the problem before? No. Okay, so this is interesting, because in the documentation it says AI.generate stream and it uses await. Well, anyways, so I'm going to say we'll get the response here and then the stream, And let's see, so all the structured elements are unused, right? So, and here we can see how the response will look like. It's going to be a promise, and it will have the summary and the answer fields. So we get this, and then down, yeah, this look good. Please, can I get this again? Well, I can write it myself. Okay, for await const chunk of stream, and then we're going to log this out. And then down here, what we want to do is we want to await the response just like here. So, and this is very similar to what we had before, right? So let's just do this. Const output equals await response, and you can see that the compiler is happy now again down here. So let's just try this out. So I'm going to open up the console so we can see, the terminal. I don't know why I always say console. It must have to do with German for some reason. Because people are always confused when I say, let's look at the console, and what I'm referring to is the terminal. So save, and this should compile now, and then I'm going to go back into our app here and pull this over here, and then let's try having a chat. How can I use SF symbols in my Swift UI app? Okay, there is a call. Okay, nice. So let's go back and take a look at what happened here. So you can see that, let me scroll to the very beginning of this. So here we have the call to our model, and you can see that that's something different, I guess. But so here we call generate response or generate response chunk, and you can see that we get an answer back. And okay, so here is the previous chunks. And we should probably, to make it easier to read, okay, so how about accumulated text? How about this? Let's try this. Okay, let's go to the bottom. And then call this again. And let's ask something else. Can you create custom SF symbols? Nice. So, and again, you can see that the client app continues working. So I didn't make a change to the client app, so it's got the same behavior, and that is because we awaited the response here and then returned it just like that. But we can see that it's a little bit hard to read. But you can see that we receive chunk by chunk. Yeah, here, you can see it here. So here's the answer. Yes, you can create custom SF symbols. The SF symbol app allows you, and then we receive the next chunk, and the answer is allows you, and then it goes on to combine existing SF symbols with adornments, or you can create entirely new symbols, and then the chunk ends. And then, so here is the end of the chunk, and then it goes on, and then yet again. Right, so this is working really nice. And ooh, wow, nice. Oh, thanks for telling me all your screen resolutions. So Martin uses a phone, So hopefully you can read the font, but you will hopefully appreciate that I read back everything that's happening on screen. Lars has a 27-inch monitor, other people have a large 27-inch monitor. Great. So a huge range of resolutions, I imagine. We'll make it work. If it's too small for you, you need to let me know, but I hope this works. Okay, so the backend implementation works nicely. So what we need to do now is go and call this on a front end. So let's go into Xcode. Oops, nope, like this. Okay, and let me Okay, so double checking that you can see what's important, and also maybe we can, okay, this is nice. Okay, Command plus. So did you know that works in Xcode? Command plus for increasing just the font. That's really, really nice. If you do the same, Command plus in VS Code, the entire UI scales up and down. I mean, there are probably good reasons for both. I think I prefer that I can zoom only the text. That seems to be very very useful to me. Okay, here is our semantic QA service, and this is where we call our function. So here is the name of the function we call, semantic QA flow callable. And we can call it because we import the Firebase functions SDK. And you can see that this is a HTTPS callable. So let's now see if we are on the latest version of Firebase, so 11.9. Let's double check. I never know what's the latest version. So github.com, and the latest release is 11.12. So let's upgrade to the latest version. Update package. Okay. Oh, here we go. And then let's have a look at the code and see how this works. Just search for stream. Okay, so stream. This is a private function, and make requests. So these are private functions as well. No. No, let's go. So let's filter. So unfortunately, this is now pretty small. So we've got make request for streamable content URL, callable stream result, and I think this one here is the only public method. So func stream at blah, blah, blah. So let's see if we can find any callers. No, we can't because Xcode is not smart enough for this. Yeah, so we can see it in the mock data, but it's really not the function. Okay, we'll just try. Okay, I am going to create a duplicate of this function. And then I'm going to call it query stream, and then we can start updating this. So hello. Oh no, we don't get code completion. That is not great. Ah. And you know, the thing is, because we now have predictive code completion, it probably makes stuff up, right? So yeah, this is not a thing. Is it? Oh, it is. Okay. So, so this might be what we need. So it says stream add URL data. Okay, so it returns an async throwing stream. So this might be what we need. Okay. Let stream equals semantic flow.callable.stream, and then let's see what this thing here gives us. Okay, so make async iterator. So that means that we should be able to iterate over it. So now if I only remember the correct syntax. For state and try await stream. Let's do it. Okay, nice. So this rings a bell. I've seen code like this. Okay. So we iterate over the stream, and then we switch on the state, and then it can be either of two, so either a response or an error. Let's double check. Yeah, well, it can be more, right? Oh, wait, haha, this is what I defined. So this is something that I probably implemented. Oh, look at that. It's over here. Okay, so I think I created this before, and then I forgot to throw it away. Okay, anyways, so let's look at the implementation. And that is why it's still here. Okay. And maybe I wonder, so let's see, maybe I'll double check afterwards. Let's go through the implementation first, and then we'll see if I accidentally made it work without wanting to make it work. Here is query streaming, and here we get our callable. So we define the callable like we did up here. So this should literally be the same, right? Except that now we say we need a stream response, and that stream response has two generic parameters. And in this case, they're both the same, but oftentimes you would define them differently. So if you look at this, you can see that the first one is message and the second one is result. So message is what you get throughout the stream. So all the different chunks will be in there, and result will be what you get at the very end. And query is our input parameter. So what we do here is we define a callable function, and we say query is our input parameter, and we want a streaming response. And then we call the .stream method on it and send our query. And the result will be the stream, and then we can do for try await response in stream, and the response will have will be either well, you know, how many are we? We have message, we have result. So it can be either one of the two, right? So the message will be the payload, and result is what we get at the very end. And then here in the switch, we can go over it and say, okay, if we receive a message, we will get the message and retrieve the answer field from the message. And this works because, hello, well, code completion doesn't really work well today. And this works because we're making use of Codable. So by defining the return type of the function like this, we tell the Firebase Functions SDK that we want to use Codable for encoding and decoding messages. So, and if you look at the response, here, you can see that it has a summary and an answer field. So this is what I defined before to be able to say, well, you know, this is what we get back. And this is exactly the same struct that we used when we didn't use the streaming function. So we can just continue using it. So, and then we will keep on getting those chunks from the remote API, and we'll receive them in our for loop. And one of the things is we print them, and then the other is that we want to send them back to our caller. So the caller is our UI, and I want to use an A-string stream to listen to what we get back from our function here. So let's quickly go into our UI to take a look at how this looks like. So find selected text in workspace. No? Okay. Because we'll still have to implement it, I guess, right? So let's see if we get a call hierarchy for this one. No, we don't. Well, we'll have to do it manually, I guess. Okay, so here is our conversation view where we call this the service. So on send message, we get what the user entered. We'll create a chat message, and then we'll call the semantic QA service. And here's our query. Here we go. Now I am really confused. Do you know? Oh, I know why. Okay, so now things start to make sense, because this file here, this is not part of the project. Let me prove it to you. Right? So if I go into this file here, semantic QA servers, we can see that it lives in the project. It is part of the target. And this one here, I probably opened that in a different Xcode window or in this one, and so it's just here. It's just somewhere else. Can you go there? No, you can't. No. And, you know, pressing Command Shift and J doesn't even go there. Well, and this is why we weren't able to back navigate. Anyways, we were in the UI. So in the UI, we call query, and this is the non-streaming version. So we pass in the query and we pass in the history, we get the response, and then we take the response and append it to our chat window. So that is how it currently works. So what we want to do now is we want to use the streaming version. And what I'm going to do is I'm going to copy this thing here and just paste it over. So, And stream state is still missing, so we'll take that. So stream state. And we'll add it to our file just up here. Okay. Good. So this returns an A-string stream. So now in the caller, let's see. So try await semantic QA service dot query. So try, well, semantic QA service dot query streaming. Xcode, come on, help me. Query streaming, we pass in our query, we pass in the history, and the result is it's unused. Let stream equals, no, let's see what the stream is. So the stream is an async stream for await response in stream. Okay, so no, that's not how, sorry, that's not how it works. So response is a stream state. So we need to switch on the response, right? So switch response, case, loading, error, and response. Where is this coming from? What's this? Okay. Ah, it's how did this happen? Okay. Participant is self. No, it's not self, but it is answer dot. Okay. Switch must be exhaustive. Loading response completed an error. Loading response, and then there is completed. Case completed. Yep. Let response. And then we can just print the response here. Response dot answer. And maybe we should also say response completed. Response dot answer. Okay. And let's see what happens here. Response message, okay. Yeah, this looks good. And then what we need here is, okay, so we'll probably need to figure out how this is going to best work, because this is not throwing, is it? No. Okay, we'll leave it at as this for the moment. So what I want you to say is this part here, that is probably something that we need to work on, because what's happening is while we iterate over the responses that we get from the stream, we get those chunks. this thing here will be called for each of the chunks. And that means that we can't just say, well, we're going to append this. I mean, we can try and see what happens, but it's not going to be what we want. Okay. Let's run this. So we're building. And while we're building, I'm curious. So for the asynchronous APIs that you use, do you prefer using callbacks like the ones that Firestore, for example, has for the snapshot listeners, or do you prefer using async stream where you end up implementing something that looks like a for loop? Let me know. I'm really curious. Okay, so let's see, and I'm going to open our term. This is the console though. It's confusing. Anyways, so tell me how to call Firebase asynchronously. Bam. So, okay. Interesting. So we got the complete response, but for some reason we didn't get this. Okay, what we can do is, well, first of all, let's do a breakpoint and see what's happening here. Come again. So this does not get called, and I am curious why not. Because if we look at the log output here, yeah, you can see the user asked to reiterate the previous request, but the context, and so on and so forth. So clearly, this was sent, but we're probably not doing this the correct way. Okay. Let's set a breakpoint in here. And let's go and run this again. Tell me a joke about Swift async. Okay, so here we go. Here is our response, and it wants to go into, no, oh, it immediately goes into result. That is so interesting. Oh no, connection failed. Are we running into the simulator thing again? Please not. Tell me. No. Write a long piece of code about that demonstrates how to implement an off-screen with Swift UI. Okay, let's see. No, it goes straight into the result. So I'm kind of like wondering, I don't know, is this not enough? Okay. So let's make some space here. Sing 20 bottles of beer, but with Swift UI. Okay, so here's our message. So we get multiple answers here. So it seems like this should be working. Ah, of course. So, yeah, how could I forget? So, the problem actually is the backend implementation. So I was missing a very crucial piece. So what's happening here is we do call generate stream and we do iterate over the chunks, but we don't send the chunks to the client. Instead, we'll just wait until it's finished and then we send the response. So what we need to do is we need to send this to the flow here. So now let's double check if this is already in the documentation, because that might not yet be in the documentation. So it might be. Oh, it is. Okay. Yeah, here we go. So in this part of the documentation, we can see that we define a flow just like our flow. And then here we call generate stream. And here, this is the crucial part. We use send chunk to send this to the front end. So, and I'm guessing send chunk, that is something that is available to us somehow. Oh no, here we go. So this is a callback function. All right, so let's try implementing this. Hello, can I get a handle on this window, please? Thank you. So first of all, we are going to say we have a name, we have input schema, output schema, and then response schema, stream schema. And we'll just use the output schema because we're literally going to return the same thing. At least I think. Let's see. And then we have the input, and here it's with the default value, and then we have the send chunk function. We'll just add this here, like this. Then the rest of our function is the same, and we call generate stream, and you can see that in this code sample, indeed, we don't have to use our await here, because we'll get the stream and then we will await on the stream using this for loop. And then instead of just logging it, we will use send chunk, and we're not going to use accumulator text, but chunk.text. I think like, what? Why? Ah, yeah, that makes a lot of sense. So we need, because I said that I'm going to return this in the same schema as the output schema, I actually need to send this as the output schema. So that's going to be interesting. Like this. You know, I'm The reason why I'm not sure is that so we've got text, accumulated text, because we're requesting structured data, right? So we might have to use output. We might have to use output or to JSON. Let's see. I mean, I would expect that it somehow is able to derive this. So chunk dot to generate response chunk data. What is content? Custom media data. Chunk.output.summary. So the T, what's that? Yeah, so generate response. So this is, so I would assume that this is a generic type, right? Let's try this. Nope. Do we need to as a hard typecast? All right, let's, I mean, I've got the solution somewhere. I can look up the solution, but, you know, I want, part of this is, you know, showing that we're real and that I struggle with stuff as well. So, let's try this. So go to the very end, and then I'm going to open another chat. Oh, it's because it's still waiting. Okay. Let's go in and then try this again. Hello? Why is there no input? Here we go. Tell me how to call Firebase cloud functions asynchronously. And now let's take a look at our backend. Okay, let's try this again. Also, I think what I want to do is do it this way. So, ooh, this is interesting. No, this doesn't work. So, I want to log this. Console.log, like this, like that. Make space. Hello. Okay, can I get an answer here? Okay, so we get something back. Okay. So here's an empty answer, there is an answer, and we should probably do something like this. Will this work? No, this will probably not work. Okay. Right. So, print debugging. Print debugging always works, hopefully. So, where's the response? I can't. So here's what we send, but we are not getting any response. Why is that? Okay, here we go. So beginning and beginning and beginning. So answer, beginning. Okay, so it builds it up, right? So we're logging chunk.output and we're trying to log it as summary and answer. And we first get the answer and then we also get the summary. So I'm kind of hoping that this works. So now let's see if this works on the front end. Here in our semantic QA service, we query streaming. Let's set a breakpoint here and then just work our way through. Let's start with saying hello. So we send the query, we construct our function, we yield loading, we call the stream, and now let's add a breakpoint here and another one here, and then just go. Okay, nothing is happening. Right, so here we go. We have an error message. So it's saying key not found, string value is summary, and no value associated with key coding string summary. So if we go back and look at how the data is produced here, we see that answer is being sent first and then summary, right? So for the first chunk that we send, we don't send summary, but we send answer. So if we go and look at our message structure here, we can see that these are non-optional. So I'm guessing that this is a problem because Swift will try to decode that and it will notice, oh, yeah, there is no summary. I only get an answer, and then it will say, yeah, this doesn't work. So let's see what the compiler has to say about this. And it has to say that it doesn't like it because here, okay, we'll take the easy way out. And here is another one. Here's another one. Okay. So, all right. So let's start this again, and then let's be friendly. Hello. We send the query, and we receive something back. Here's the answer is nil. Okay. Okay, now we get an optional. Right. So, and here is what I want to, what I mentioned a while ago. And I should probably also move this over so you can see what I'm typing into the chat window. All of these are the responses from the model, and I'm going to do this again, and then I'm going to show this again without having the breakpoints in there. Tell me what you know about Swift UI. So now we get the chunks back, and you'll see a bunch of responses here. And so first of all, we see an empty response, another empty response, and then we see those incremental responses here. And the beginning is always the same, and then it just goes on and on and on. So, and this is why here we need to be a little bit smarter about what we do with the response. So we get the response message here, and instead of appending it to the response message, we need to know which is the method that, which is the last chat message. And let's see, so I think we had something in place already. We used to, at least. Okay, so this is the user message. This is the history. Yeah, so I think what we need to do is we'll need to create an empty message and add this, and then just keep on updating this. The reason why I'm thinking about this now is that I am absolutely sure I had this, but this might be because I am working on different versions of the app. So this is the user message, and then we'll just we'll pull this out and put this here. And we'll do it this way. So we've got the response message. And we also need to add it to the messages. So So let's do it here so that we don't add it to the history, because we don't want that to be part of the history. So messages dot append, and then response message. So this is a let. And then instead of doing this, we'll get the messages messages dot count -1. So we'll get the last message var updating message equals this one, and then updating message dot, oh no. So messages at message.count -1 equals, and then we put the response message. Right. Let's see. Right, here we go. How can I use Firebase Data Connect in SwiftUI? Here's the thinking message. Oh, okay. So it seems to work. Now let's try to get a longer message. Also, what we can do is we can use fancy breakpoints. So I'm going to add an action, and I'll add a sound. So which one is nice? Okay. So turn up the volume. I don't know if you can hear this, but maybe you can. Is this enabled? Okay. And then what we also want to do is we want to automatically continue after evaluating. Oh, I shouldn't have restarted. We can just continue. Good. So here is the app. Let's try to get a long answer. Show me code for, what do we have in here? Main actor. For using main actor in a Swift app that calls some asynchronous remote API. We don't need this one anymore. Yeah, so we don't also need these. Can you hear that? Okay, so we got four beeps there. So let me find something that is long enough. Task.sleep versus task.yield. Let's try that. What is the difference? Between task.yield and task.sleep. Okay, we'll try one more time. It depends on the data, and I need to find something that is long enough. Write a long, oh yeah, that's it. Write a long blog post about task.sleep and task.yield. Come on. What? So what is the problem here? Let's see. So let's find out what the problem is. And I think one way to do that is to go into the GenKit developer UI, which has been running in the background. And we can see that here's our trace. Let's make it larger. So here's our trace for the most recent query that I sent, and we can have a look at what's going on. So write a long blog post. So that's definitely what I last sent, and here's our answer and the summary. So what we do is we rephrase this, and this is this is something that we implemented a while ago to make sure that even if we have a long conversation, that the model is able to answer, because we summarize the conversation. So that is the first part in the rephraser here. And then we use Firestore artifacts to retrieve the documents. So let's see what it comes up with. So it uses this as the input for the retriever. And what do we get here? So we get documents, we get a content. So we have something about Firebase Data Connect. So that's the first thing we get. Then we get, this is still the first thing. So it is how relationships work in Firebase Data Connect. Let's go on. So the next thing that we get is announcing Firebase GenKit for Node. Then the next thing is, so we should get 3 things. Data Connect, all about schemas. So interesting. So, oh yeah. So apparently blog was a very strong indicator, right? So I said, write a blog post. Write a long blog post about the functionality of task.sleep. So apparently blog post was such a strong signal that it retrieved all those documents that had blog posts in them, and these did not talk about anything that is related to Swift. So the second part of the question was that, the model was not able to answer that. So let's use that knowledge now and say, write a long blog post about building AI apps with GenKit. Let's see if this works. Yeah, here we go. Here we go. Nice, nice. Okay. Awesome. Okay. And here's the thing. So you can still hear the sound coming, and that is because, obviously the code executes much faster than you can play the sound, because the sound takes a while to play. So we'll just turn it off again. So where are our breakpoints? I think it was this one. Was it? Yeah, it was. Okay, so I'm going to turn this off again. And then let's go back into our app. So I'm going to insert a few empty lines. And then let's do this again. Write a long blog post about, and let's do Firebase Data Connect now. Thinking. And here we go, right? So you can see that it's still going on in the background, and the stream arrives here. And because we don't automatically scroll to the bottom, because that would be bad UX, we can't see it, but you could see it in the beginning. So let's try it again. Let's do this. Write a long blog post about GenKit, and then watch what happens. Did you see it? So it's building up gradually. So this is exactly what we wanted. And at the very end, we will receive the final result, which we, technically speaking, don't really need anymore, but it might be different, right? So if we go back into our backend implementation, you can see that in the definition of our flow, well, you can't see it because it's too narrow. Here we go. So in the definition of our flow, we specify the input schema, that is what the query that we send in, and we define the output schema, and we define the stream schema. And these could be different, right? So we could be saying, well, we use a different schema for the streaming response than we do for the output. And that would have an impact here, right? So let's try this. So for example, if I went in and said, oh, as the output schema, I don't want this one, but I want z.string like this. And now I get a compiler error, actually, because it says, well, so the type promise summary string answer string is not assignable to the type string or promise string, and that is because at the very end we don't return a string, but we return this thing here. So if I comment this out and then return a string, we should be fine. Return hello. Now let's go back, and boom, the compiler error is gone. So that means you can return different data in the stream than you do in the final result. So why would that be interesting? I don't know. I don't know. Maybe you want to stream. Yeah, so you want to stream something like, I don't know, maybe you want to stream the weather. So you stream the weather responses for, let's say you have a weather app that allows the user to retrieve the weather forecast for 100 locations. So you start streaming, and as you retrieve the weather forecast from the remote weather services around the globe, you'll send them to the stream, and the data that you send back is the temperature, the precipitation, and pressure, and all of those other things. So that's what you send on the stream. And then once you finish, you'll send just a summary, and you'll send maybe information about, hey, this is the weather report for what's the time, for 9:30. We retrieved the weather forecast for 100 locations, and this information was brought to you by Squarespace or whomever. So I'm not paid by Squarespace, just pulling a joke here. That might be what you can do if you use a different output schema than a different stream schema, right? And on the client, you would implement this like this. So if we go into our QA service, where you can see that we have our definition of the callable, you can see that we have a stream response. And instead of typing it as response, response, you would say, so message is what we received throughout the stream, and a second parameter is the result. In our case, you would say stream response, string, right? Because we decided to return a string as the final result. All right. Hey, Stefan. Yeah, Cloud Functions for the win, right? Thanks for dropping by. And yeah, so I think that was what I wanted to show today. So Stefan, if you just tuned in, I'm really sorry. If you ask me a good question, I'm happy to answer that question. So I'll give you half a minute, Stefan, to come up with a really good question. Yeah, what a timing. What a timing. Okay, let's see. Let's see if I had something else that I wanted to talk about today, but I think, you know, that was mostly it. Yeah. Yeah, it was. Yep. So, you know, here's another thing. In this week's newsletter, and also in last week's newsletter, and why am I talking about it? I can pull it up. So, go to newsletter. So I found an interesting article about Swift error messages, and in the last episode I covered this already, because it's a multi article series apparently. So Jihad wrote about how to make Swift error messages more friendly, and if we go back to issue 80, you can see the article that I'm referring to, Swift error handling done right, overcoming the Objective-C error legacy. Let's go there and take a look. So, you know, he describes, well, you know, oftentimes you go to great lengths to define error messages, and then all that you get is, you know, something that is unexpected. So for this error here, so we define a network error, and it has a really nice error message, and then we expect to have this really nice error message here, and what happens is the operation couldn't be completed. And then appname.network error, error 0. And so he goes through to explain why this is and how to resolve it for it. And then he ends with, oh, and by the way, I implemented an open source library. It's called ErrorKit. So let's go here. So ErrorKit, FlyingDev is Jihad's, I don't know, is it his company name? Apps and developer content by Jihad. Well, there you go. So it's his GitHub alter ego, if you will. So, and the cool thing is that you can use this to basically define error messages that make sense. So coming back to where we came from, well, yeah, here we are. So in the latest blog post, he writes about how he is looking for people to contribute to this. So again, he explains it. And then the solution, community curated error mappings. And apparently this not only works for system error messages, but also for all sorts of other error messages. I'm not looking at any particular SDK here, but you know, I imagine it might be useful for all sorts of SDKs. And so he's asking other people to contribute, and he, you know, here are 3 things: spot a bad error message, write a better version, and submit it on GitHub. Let's see, is there, if we go in and open an issue, new issue. Oh, I need to sign in. Well, anyways, and it looks like some people have already submitted something, right? So long story short, I reached out to Jihad and asked him, hey, would you be interested to come on the stream? And he said yes. So now it's only just a matter of finding a date that works for both of us, and then we'll have a collab and we'll look into all the error messages that are in my second brain application, and we'll work on making them better. And hopefully that's going to be, well, not hopefully, I'm absolutely sure this is going to be a fun one. So stay tuned for that. It's going to be the next one or the one after that. But because I'm traveling next week, it's going to be at least 1 or 2 weeks before we do that. So let's see if Stefan has had enough time to come up with a good question. All right, so this is a really good question. So Stefan wants to know, when would you opt for a Google Cloud let me get the naming right. When would you opt for a cloud function for Firebase versus a Vapor server? So I think I would probably use a cloud function if the code that I write has anything to do with Firebase. For example, you can write Firebase cloud functions if you want to trigger something when the user or when your application writes something into the database. So that is extremely tightly integrated, and writing a cloud function that triggers when a document is updated or when a document is deleted or modified, that is, it's pretty straightforward. It doesn't mean that it's impossible to do with Vapor, and Vapor has integrations for databases as well, and I assume they have an integration for Firebase as well, but it's just a little bit more tightly integrated with Firebase cloud functions. So that is one reason. And then I'm not entirely sure if a Vapor server needs to be always on, or if it's going to be waked up when it's needed. But for cloud functions, you can specify if you want them to stick around or if you want to scale down to 0, and that's something that you can easily define on a cloud function. Depending on which language you use, you can either do that directly in your code, and you can say, well, for this cloud function, I want to have a min instance count of 1, and that means there is always going to be one of your cloud functions around. Or you can say, well, I don't care about min instances, I want to scale down to 0, and that means if there is nobody using your cloud function, it will just go down to 0, it will sleep, if you will, and only when there is a user that needs this cloud function, it will be started again. It takes maybe a second or two, and then it can serve that traffic. Oh, and also, obviously, it's a language choice, right? So Vapor allows you to write code in Swift, and if you use cloud functions, then it's either going to be TypeScript or JavaScript or Python, and you can use other languages as well, but it's slightly more complex to set this up. So if you're interested in getting support for Swift functions, here's what you can do. Firebase.uservoice.com, and you can go to the Firebase user voice, find support Swift and cloud functions, which was requested by Morten, who was on the stream as well earlier today, and you can sign in and upvote this, because the more upvotes we get, the more likely it is that I can convince my PM to actually scope this and have us implement this. And given that AWS supports lambdas or Swift for lambdas as well, I think it's only fair that we support it as well. But it's always a numbers game. The more people want it, the better or the easier it is to convince the company that this is worthwhile. So please upvote this. Awesome. And with that, I think we can call it a day. Thanks for tuning in, and I will see you maybe the week after next week. I'll definitely post on social media. And if you've got any other topics where you think, oh, it would be amazing if Peter brought in so-and-so to do a collab on it, let me know, and I'm happy to make it happen. All right, thanks everybody. I will see you in the next one.